Hello everyone, I'm Frank, and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Sum Sum by Vithik, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have descension arrows, where digits along an arrow sum to the digit in the circled cell, and they must descend away from the circle. That is, digits cannot repeat. So, for example, we could have something like, say, 6, 2, and 1, and this would add up to 9. Because the digits along the arrow must be decreasing, going away from the circle, which they are, and they must add up to the digit that's in the circle that's connected to it, which they do. 6, 2, and 1 add up to 9. So that's an example of how descension arrows work, and that's one part of the sum. The second part of the sum is sum squares, where a digit on a square is orthogonally surrounded by digits that sum to its value. So if we had, say, 1, 4, 1, and 2 here. So what are the orthogonally surrounded by digits? That means that cells that share an edge with it. So for example, this square would be the sum of all 4 of the cells that share an edge with it. And 1 plus 1 plus 2 plus 4 adds up to 8. So that's an example of how these sum squares work. And that's the second sum of the sums. And so for the example, this square would be the sum of these 3 digits. The sum here would be the sum of these 4 digits. The sum here would be the sum of these 3 digits, etc., etc. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so every 3-digit sum is going to be the sum of so anytime you have 3 digits adding up to uniquely adding up to anytime you have 3 digits and they must be unique and they must add up to a single digit, you're guaranteed at least 2 of them have to be from 1, 2, or 3. Because just look at all the combination. 1, 2, and 3 adds up to 6. That's 3 of them adding up to 3. Again, I said at least 2 of them must be 3 or less. 7 has 1, 2, and 4, which has 1 and 2, which are 3 or less. 8 can add up with 1, 2, 5, 1, 3, 4. Again, both of them require 2 digits that are 3 or less. And 9 can be 1, 2, 6, 1, 3, 5, or 2, 3, 4. All of them require 2 digits that are 3 or less. So, for these sets of digits, we know, first of all, then these have to be all blue. And this must be smaller than that, so this must be 1 or 2, and this is 2 or 3, because this must be greater than that one. These are also low here. So we have 1 and 2. Oops. And 2 and 3 as possibilities. We know the digits in the circles must add up to at least 6 for those 3-digit sums. Also, if we have 2 digits adding up to another digit, the smaller one must be 1 through 4, right? If you have it trying to be 5 or greater, that means it's 5 is the smallest number. 5 plus 6 adds up to 11, which is not a single digit. So this has to be small, and this must be small also. So these are all small digits. These are all small digits, which must be at least 1 through 4. Well, anytime you have a square with all the potential sums in the same box, that also must be, that's 3 unique digits trying to add up to a single digit. So this must be 6 through 9 here. And again, we have 2 of these digits must be from 1, 2, or 3, at least. We know this is bigger than this one, so this has to be at least 2. And we have 3 digits here, adding up to at least a single digit, plus this. Well, these add up to at most, at least 1, 2, and 3, which means this cannot be 4, because then this digit would have to be 6 at minimum plus 4, which is 10, which is not a digit. So this can't be 4 here. This is 1 through 4. Well, we know, again, so if this tried to be 6, that would be 1, 2, 3 here. This would be at minimum 1, 2, 4, which is possible. But we do know that, again, to add up to, this is going to be plus 1, at least. So this must add up to 8 at most here, which means 2 of these digits must be from 1 through 3. 2 of these digits must be from 1 through 3. But it could be the same 2 here. I wasn't thinking that, but interesting. We know this digit is equal to the sum of these 2 digits. But these 2 digits plus these 2 digits add up to this digit. So this must be at least these, subtracting these 2 less than this. So this would have to be 6 at most, right? 9 plus these 2 digits would be, so these 2 digits would be 1 and 2 at minimum. So 9 minus 1 and 2 could give you 6 at most here. So this is 6 at most. It has to be down to 3. So that means this digit is 5 at most here. So then it has to be greater than this because of the dissension arrow. So this is 2 through 5. Okay. What else do we have? This digit is equal to the sum of these 2 digits plus this digit. Sorry. It's equal, yeah. This digit, sorry. This digit and this digit have to be different. This digit is equal to the sum of these 2 plus these 2 digits. This digit is equal to the sum of these 2 digits plus that digit. But this digit is guaranteed to be 2 at most. And because this is 2 at most, this is going to have to be a bigger sum. So this cannot be 9 here. This digit must be greater than that one, because they have the same sum here, but then this is guaranteed to be smaller than this pair here because these are different digits. So this is 7, 8, or 9. Can we have a 4 in either of these? If we have 4 and 1, that adds up to 5. But we know that these 2 digits are guaranteed also to be at least 5. So that doesn't work. So these cannot be 4 here. Interesting. So these are all 1, 2, 3 sets. Interesting. So if this were 3, this would have to be 2 and 1, but these did 3, 2 here, and the 1 here all see this cell, which would eliminate all possibilities for that cell. So this cannot be 3, which means this can't be 2, because if this is 2, this is guaranteed to be 1, and therefore would add up to 3, if that were the case. Okay. So what else do we have here? The sum of this The sum of this digits, oh, this is at least 3 here. Yeah, it's at least 3 and can be up to 6. Same here. This is 3 and it could be up to 6. But this can't be 6 anymore because it can't add up to 9 here. So this is 5 at most here. This digit then must be at least 1 and 3 here to add up to 4, and 1 and 2 here to add up to 7. So this is also 7, 8, or 9 here. So if this were 4, this would have to be 5 here. And these would be too large to add up to this square, because 4 and 5 already add up to 9. And then plus these two would be way too big. So this can't be 4. Can it be 3? 3 and 4 plus 1 and 3 already adds up to 11, so no 3 there. You could have 2 and 3. That does work. Can you have 2 and 4? No, because 1 and 3 adds up to 4, plus 2 and 4 adds up to 6. 4 plus 6 is 10, which a single digit obviously can't be. So this must be 2 or 3 here. Interesting. Well, that means this is either 1, 2, 1, 3, or 2, 3 here, which means this is 3, 4, 5. It cannot be 3 here because of the 2, 3 pair in the box. So this is 4 or 5, which means this can't be 2. If this were 2, that forces this to be 1, and therefore this adds up to 3, which is not possible. So this must be 3 here, which makes this 2, which makes that 1. And we have 4 and 5 here. So this is 1, 2, and we don't know what this is. This can't be 1 anymore because of 1 in the column. 2 eliminates 2 here. 3 eliminates 3 there. So this must be greater than 2 or 3, but it can't be 2 or 3, so this is at least 4. So 2 and 4 add up to 6. It could be 5, 6, or 7, with that being 7, 8, or 9. Okay. This square is a sum of these digits, so these cannot add up to 9. And they must add up to at most 6, because we have 1 and 2 here already adding up to 3. So this must add up to 6. So this is 2 and 4 adding up to 6 there. That makes this 9, because that's the sum of the digits that share an edge with it. 6 eliminates 6 here. 2 eliminates 2 here, so this is 1. 1 and 3 add up to 4. This cannot be 4 anymore because of 4 in the column, so this can't be 7. This adds up to 2 eliminates 2 here. This is 1 or 3. This is 2 or 3. Square, so this is 2 and 2. This cannot be 5, because if this were 5, that would already add up to 9 for these 3 digits, plus that digit would make that 10. So this has to be 3, which makes this 1, which makes that 2. 1, 2, 2, 3 adds up to 8. 1, 2, 3 adds up to 6. 1, 2, 3, 3 adds up to 9. So this can't be 2 here. This digit must be greater than 2, so it has to be 3. And this digit must be greater than 3, so this has to be 4, which adds up to 9. 4 eliminates 4 in the rest of the row. Okay. Which means the remaining digits in the central box are 4, 5, and 7. Okay, and this can't be 4 because of 4 in the column. 1 and 4 add up to 5, 1 and 5 add up to 6, 1 and 7 add up to 8, but this can't be 8 because of 8 in the column, so this can't have a 7 there. This is already 4 here. Remaining digits in row 7. We have 1, 5, 7, 8 remaining. It obviously can't be 1 because of 1 in the column. If we try to have anything greater than 5, anything 5 or greater here, that already adds up to 4 plus 5 plus 1, which is 10, which is not possible. So this must be a 1 here. That eliminates 1 in the rest of the row. So we have 3, 1, 1 here. That's already 5. We could have 2 here. We cannot have 3 here. So 3, 1, 1 already adds up to 5. So plus another digit, it's never going to add up to 5. And if we try to have 3, 1, 1, 3 adding up to 8 here, that's not possible because of 3 in the column. So this must be 3, 1, 1, and 2 adding up to 7. So that eliminates 7 in the rest of the row. Okay. So these are done, these are done, these are done. 3 eliminates 3 here, so this is 1. 1 and 3 add up to 4, 1 and 5 add up to 6. We're not sure which one is which. Remaining digits here. So this is at least 4 here. So that means these two digits add up to 5 at most, because 5 plus 4 could add up to 9. We're guaranteed this is 4 at least, at 3 at least, so that makes this 7 at least. So 7, 8, and 9, these add up to at least, at most 5. So that's 1 through 4. No 1 or 4 here because of 1 or 4 in the column. No 4 here because of 4 in the row. Um... What does this add up to? So this is at minimum 3 here. So this is at minimum 3, 1, 1. So this could be 5, 7, 8, 9. But this can't be 5 or 7 because of the 4, 5, 7 triplet in the row. So this can't be 3. This is at minimum 1, 2, or 3. To add up to 8 or 9, we have a 1. It could be 1, 1, 6, or 7 here, but it can't be 6 because of 6 in the row or column. And therefore, this could also be 3, 4, 5. But it can't be 3 here. 3 plus 1 plus 2 at maximum adds up to 6. So this can't be 3. You could have 4 plus 1 plus 3 adding up to 8. 5 plus 1 plus 2 adding up to 8. 5 plus 1 plus 3 adding up to 9, or 7 plus 1 plus 1 adding up to 9. Okay, remaining digits in row 4. We have 2, 6, 8, 9. Obviously, this can't be 2 because of 2 in the column. This can't be 9 because of 9 in the column. Okay. To add up to 7 could be 1, 2, and 4. To add up to 8, 1, 3, 4, or 1, 2, 5. And to add up to 9, it would have to be 1, 2, 6, 1, 3, 5, or 2, 3, 4. Okay. This can't be 9 because of 9 in the row, so we don't have 6 available. So this is 4 or 5. If this is 1, 3, this is 4. If this is 1, 5, this is 6. So this is, one of these is 4 or 5. 9 eliminates 9 here because of 9 in the column. So we don't have 4 or 5 available in the rest of this upper left-hand box. 1 can't be here, 1 can't be here because of 1's in the column, so this must be a 1 here. So we have a guaranteed 1 there. 1, 1. Interesting. Again, we can't have 4 or 5 available in the rest of this upper left-hand box. So what does that leave us? 2, 3, 6, 7, 8, 9. This can't be 2 or 9 because of 2 or 9 in the column. What else do we have? What are the possibilities here? We could have 4 here, 1 and 4 adding up to 5. 1 and 5 adding up to 6. 1 and 6 adding up to 7. There's no 1, 7 possible, and we can't have 1, 8 adding up to 9 here. This can't be 4 and 5 adding up to 9 here because of 9 in the row. So this is 1 guaranteed here. That leaves a 1 there. We have, where is 1 in this upper right-hand box? Can't be here or here because of 1's in the column. Can't be here or here because of 1's in the row, so 1 has to be there. That gives us 8 1's. We know where the last 1 has to be. It has to be here. Okay. Remaining digits of row 6. We have 4, 5, 6, and 7. No 6 here because of 6 in the column. No 4 here because of 4 in the column. No 4 here because of 4 in the column. And we have a 4, 5, 7 triplet in column 1, which eliminates 4, 5, and 7 in the rest of the column. So no 7 here, it's 8. No 8 here, it's 9. And we have a 2, 3 left here. This can't be 2 because of 2 in the row, so that's 3, which makes that 2. 8 eliminates 8 in the rest of the box. Also, we are guaranteed a 7 here because of the 4, 5, 7 triplet there, so this cannot be 7 there. This is either 1, 2, 5. Sorry, 1, 2, 5 adding up to 8, or 1, 3, 4 adding up to 8. If this is 1, 2, 5, that would force this to be 1, 2, 3, adding up to 7. That does work. If this is 1, 3, 4 here, that doesn't work because that's 1 and 5 here, adding up to 6, and 1, 3 plus 1, 5 adds up to 10. So this must be 1, 2, and 5 here, adding up to 8. That eliminates 5 here. This is a 4, 7 pair. 5 eliminates 5 here, so this is 3. 1, 3 adds up to 4 here. And 1, 3, 1, 2 adds up to 7. So this is 7 there. No more 2 or 7 here. No 3 or 7 here, so this is 6. That forces this to be 9. 4 eliminates 4 here, so this can't be 1, 4 adding up to 5. 6 eliminates 6 here, so that's 8. No more 8 or 9 in row 4 because of the 8 and 9 there. Remaining digits in column 3, we have 5 and 7. This can't be 7 because of the 4, 7 pair in the box, so this is 5 here, which makes this 7 there. 5 eliminates 5 here, so it's 6. That eliminates 6 in the rest of the row. And we are left with a 3 in this left central box, so that's 3. Remaining digits in column 2 are 5 and 8. Okay. Remaining digits in row 2. We have 5, 3, 5, 6, 7. And this can't be 3 or 6. Where is the 3 available in row 2? It has to be here. Okay. Remaining digits of row 5 are 4, 7, 8, 9. No 9 here, no 7 here because of digits in the column. No 4 there, same. So we're guaranteed a 6 here. Remaining digits of row 8 are 5 through 9. No 9 here, no 9 here, no 8 here because of digits in the column. We have a 5-7 pair in column 5, which eliminates 5-7 in the rest of the column, so this can't be 5, it's 8, which means this can't be 8, it's 5. That eliminates 5 in the rest of the box, and 8 in the rest of the box. The remaining digits of column 5 are 2 and 9. This can't be 9 because of 9 in the row, so this must be 2, which makes that 9. Yeah, this is all just normal Sudoku now, because we've gotten pretty much, well, I guess just these 2 arrows. Hmm. Oh, these 3 digits must add up to 9 here, so this must be 7, which makes this 4. 4 eliminates 4 in the rest of the row. This becomes a 5-7 pair. That eliminates 7 in the rest of the box. So this is 4, 8, 9. So that's done. So which ones are done? This is done. This is done. We have that done. That done. That done. This is done. Done. Here. These are done. 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 And done. We'll just have those 2 arrows. Okay, remaining digits of row 1. We have 3, 4, 7, 8. Obviously, there's no 3 or 8 here because of 3 or 8 in the column. No 3 here because of 3 in the box. No 3 here because of 3 in the column. So where's the 3 in row 1? It must be here. 4 eliminates 4 here. And this 7 eliminates 7 here, so that's 8, which eliminates 8 in the rest of the row. We now have a 4-7 pair in this upper central box that eliminates 4 and 7 in the rest of the box, so no 7 here. It's 5, which makes this 6, which makes that 7 to add up to each other. So that's satisfied. 7 eliminates 7 here, so it's 5 and 7. These can't be 7 here because of 7 in the box. 5 eliminates 5 here, so this is 6, which is a sum of 5 and 1. That forces this not to be 5, it's 7. That leaves that as a 4 there. 5 and 6 eliminate 5 and 6 in the rest of the column. Where 4 eliminates 4 here, so it's 7 and 4. That leaves the remaining digit in this upper central box as an 8. We have 2 and 5 remaining in row 3. This can't be 5 because of 5 in the column, so that's 2, which makes that 5. 2 eliminates 2 here, so it's 6 and 2. 8 eliminates 8 here, so that's 4 and 9. 7 eliminates 7 here, so it's 5 or 6. 6 eliminates 6 here, so that's 8. Therefore, there's no 8 here. 8 eliminates 8 here, so it's 5 here and 8 here. 5 eliminates 5 here, so it's 6, which leaves this as a 5. 6 eliminates 6 here, so it's 9. 8 eliminates 8 here, so it's 4, which makes this 9, which makes that 8. 9 eliminates 9 here, so it's 7 and 9. And the remaining digits here are 4, 6, and 3 in the corner, which we celebrate because we solved this puzzle. This was slightly harder than very easy. But is it difficult enough to go to the easy level instead of very easy? I don't know. I feel like that this is something that anybody could sort of come up with and deduce, even if you don't have very much experience with arrows. These are all very easy deductions to make. So, yeah, I think it still qualifies as very easy. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.